This is SpaceTime Series 26, Episode 30, for broadcast on the 10th of March 2023. Coming up on SpaceTime, how mysterious Venus may be resurfacing itself. Astronomers discover mature-looking galaxies in the early universe. And the United Launch Alliance says the new Vulcan rocket could undertake its maiden flight in May. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study based on archival NASA data suggests that the planet Venus may be losing heat from geological activity in regions known as coronae, possibly like early plate activity on Earth. The findings, reported in the journal Nature Geoscience, may help explain how Venus cools down. We all know Earth uses a combination of volcanic activity and plate tectonics through mantle convection in order to lose internal heat. But Venus doesn't have any visible plate tectonic activity, possibly because its surface is too hot and malleable. As well as being Earth's nearest planetary neighbour, Venus is also considered to be Earth's sister planet. That's because they're both almost the same size, with similar mass and diameter, and they were formed under similar conditions, out of the same material and in the same part of the solar system. In fact, Venus once excited speculation that it could host the first human colony in space. See, scientists thought the dense cloud cover around Venus meant lots of rain. After all, it's closer to the Sun than the Earth, so temperatures would be hotter. That would mean lots of water, lots of evaporation, and hence lots of rain clouds. So, scientists envisioned that under its thick cloud cover, Earth's sister planet could have been covered in lush green tropical rainforests. Think of the Amazon jungle on steroids. But if Venus is Earth's sister planet, then it's a twisted sister. Soviet and American spacecraft have revealed that Venus is the closest thing to hell in our solar system. For some reason, Venus has developed a runaway greenhouse effect. Its surface is scorchingly hot, with average temperatures of 462 degrees Celsius. That's hot enough to melt lead. And those thick, opaque planet-shrouding clouds, well, they do cause rain, but the rain isn't water. It's droplets of metal-eating sulfuric acid. Scientists have seen what looks like snow caps on some of Venus's tall mountain ranges. But the snow isn't frozen water, it's actually metallic. Venus's clouds are so heavy, they crush Venus's carbon dioxide-rich atmosphere, acting like a lid on a pressure cooker. And that results in the planet having a surface pressure some 92 times greater than the average sea level surface pressure on Earth. The surface of Venus is dominated by well over 1,600 volcanic structures. That's more than any other planet in the solar system. Its surface is 90% basalt and consists of a mosaic of volcanic lava plains showing evidence of regular periodic resurfacing by floods of lava. All this indicates that volcanism has played a major role in shaping the planet's surface. In fact, Venus may have had a major global resurfacing event about 500 million years ago, based on the low number of impact craters on Venus's surface. Radar sightings by NASA's Magellan probe revealed evidence of comparatively recent volcanic activity on Venus's highest volcano, Mount Mons. Scientists detected ash flows near the summit and on the northern flank. Although there are many lines of evidence that suggest that Venus is likely to be highly volcanically active today, present-day eruptions at Mount Mons have not been confirmed. We've seen pictures of Venus's surface showing lots of shield volcanoes, widespread lava flows, unusual volcanoes called pancake domes, and arachnoid or tick-like structures called scalloped margin domes, which have never been seen on Earth. We don't really know what they do. Interestingly, Venus rotates in retrograde compared to most other planets in our solar system. That means the Sun rises in the west and sets in the east. A day on Venus lasts 243 Earth days, but Venus orbits the Sun every 224.7 Earth days. So that means a Venusian day would last longer than its year. Because both the Earth and Venus are the same size and they're made out of the same sorts of materials, scientists think they should be losing their internal heat into space at about the same rate. The new study, using the archival data from NASA's Magellan mission, has taken a new look at how Venus could be losing heat. And it's found that thin regions of the planet's uppermost layer may provide the answer. The Magellan spacecraft detected quasi-circular geological features on Venus called coronae. Making new measurements of coronae visible from the Magellan images, the authors concluded that these tended to be located where the planet's lithosphere is at its thinnest and most active. The study's lead author, Suzanne Smreka from NASA's Jet Propulsion Laboratory in Pasadena, California, says for years scientists have been locked into the idea that Venus's lithosphere is stagnant and thick. But this view is now changing. She says just as a thin bedsheet releases more body heat than a thick comforter, a thin lithosphere allows more heat to escape from Venus's interior through buoyant plumes of molten rock rising into the outer layer. Typically, where there's enhanced heat flow, there's increased volcanic activity just below the surface. So these coronae are likely revealing locations where active geology is shaping Venus's surface today. The researchers focused on 65 previously unstudied coronae that are up to a few hundred kilometres across. To calculate the thickness of the lithosphere surrounding them, the scientists measured the depth of the trenches and ridges around each of the corona. They found that the ridges are spaced more closely together in areas where the lithosphere appears to be more flexible or elastic. Now, by applying a computer model of how the elastic lithosphere bends, the authors determined that on average, the lithosphere around each corona is about 11 kilometres thick, and that's much thinner than previous studies had suggested. Also, these regions have an estimated heat flow far greater than Earth's average, and that suggests that the coronae are geologically active. Smreka says, while Venus doesn't have Earth-style tectonics, these regions of the thin lithosphere appear to be allowing significant amounts of heat to escape, similar to the mid-ocean ridges on Earth's seafloor where new tectonic plates are forming. To calculate how old a celestial body's surface material is, the standard practice has been for scientists to simply count the number of visible impact craters. A surface with few craters is fairly new, while a surface which is absolutely pummeled in craters hasn't changed much for billions of years. So, for a tectonically active planet like, say, the Earth, impact craters are erased by the subduction of the continental plates, and they're covered by molten rock from volcanoes. So, if as it appears Venus lacks tectonic activity in the regular churn of Earth-like geology, it should be covered in lots and lots of old craters. But by counting the number of Venusian craters, scientists estimate that the surface is relatively young. As we said earlier, possibly less than 500 million years old. Recent studies suggest that the youthful appearance of Venus's surface is likely due to volcanic activity, which drives regional resurfacing today. This finding is supported by the new research indicating the higher heat flow in corona regions. And that's possibly a state that Earth's lithosphere may have resembled in the distant past. Smreka says it's fascinating that Venus today is providing a window into the past which helps scientists better understand how the Earth may have looked more than 2.5 billion years ago. Put simply, it looks like Venus is in a state that's predicted to occur before a planet forms tectonic plates. This is SpaceTime. Still to come, astronomers discover mature galaxies in the early universe. And the United Launch Alliance says its new Vulcan Centaur rocket should be ready for its maiden flight in May. All that and more still to come on SpaceTime. Astronomers studying observations of the ancient universe, which have been gathered by NASA's James Webb Space Telescope, have discovered an ancient galaxy that's far more mature than it should be for its age. The findings, reported in the astrophysical journal Letters, are just the latest in a treasure trove of discoveries about the very early universe, which are forcing a major revision of the scientific literature. Last week, astronomers announced the discovery of 6 massive galaxies, each almost as big as the Milky Way, and each containing around 100 billion times the mass of our Sun. Yet these galaxies were dating back to a time when the universe was just 500 to 700 million years old, and no one knows how these galaxies could have gotten so big so quickly. It simply defies science's current understanding of galactic formation. And now James Webb has amazed scientists again. While studying data from the first images of a well-known early galaxy taken by Webb, astronomers discovered a companion galaxy that was previously hidden behind the glare of a foreground galaxy. This newly discovered companion, surprisingly, seems to have already hosted multiple generations of stars despite its young age, which is estimated to be about 1.4 billion years. By comparison, our Sun and Solar System are about 4.6 billion years of age. The study's lead author, Bo Peng from Cornell University, says the galaxy was found to be superchemically abundant, something no one had expected. Earlier images captured by ALMA, that's the Atacama Large Millimeter Submillimeter Array Telescope in Chile, contained some hints that this galaxy existed, but it really couldn't be interpreted as anything more than just random noise. Penn and colleagues estimate this newly found companion galaxy, which they've labelled SPT0418-SE, is within 5 kiloparsecs of the previously identified galaxy, known as STP0418-47, which just happens to be one of the brightest dusty star-forming galaxies in the early universe. By the way, a kiloparsec, well, that's a measurement astronomers use when talking about cosmic distances. It equates to 1,000 parsecs, or 3,260 light-years. The light from these two distant galaxies was being bent and magnified by a foreground galaxy's mass through a process called gravitational lensing, and in this case, the lensed image formed a circle, what astronomers call an Einstein ring. So you've got these two really close together galaxies a long way back in space-time. Now, by comparison, here today in our local universe, two of the nearest satellite galaxies to the Milky Way, the Large and Small Magellanic Clouds, are about 50 kiloparsecs away from us. That's 10 times further. The proximity of these two ancient galaxies suggests they're bound to interact with each other and potentially even merge, an observation that adds to our understanding of the early universe and how galaxies evolve from small ones to larger ones through merging and accretion. The two galaxies are modest in mass, as galaxies go in the early universe. SE is relatively smaller and less dusty, making it appear much bluer than its companion. Now, based on the images of these two galaxies, the authors suggest that they may be residing in a massive dark matter halo with as yet undiscovered neighbours. But the most surprising thing about the companion galaxy in this pair was how mature it is in terms of its chemical composition, what astronomers refer to as metallicity. Basically, astronomers refer to all elements other than hydrogen and helium as metals. And so this particular galaxy has an extremely high metallicity, especially for its time. The authors estimate it's somewhat comparable in terms of metallicity to our Sun. And as we mentioned earlier, our Sun's more than 4.6 billion years old already. And when it was formed, it inherited most of its metallicity from previous generations that had 8 billion years to build them up. So the authors must be seeing the leftovers from at least a couple of generations of stars that have lived and died within the first billion years of the universe's existence. And that's not what's typically seen in this particular early epoch. They speculate that the processes of forming stars in these galaxies must have been extremely efficient, and it must have started very early on in the universe. That's especially needed to explain the measured abundances of nitrogen relative to oxygen, as this ratio is considered a reliable measure of just how many generations of stars have lived and died. This is SpaceTime. Still to come, the United Launch Alliance says its new Vulcan Centaur rocket will be ready to fly in May, and the March equinox, the constellations Taurus, Leo, Corvus and Eridanus, and don't forget Pi Day, are among the highlights of the night skies on March Skywatch. The United Launch Alliance says its new Vulcan Centaur launch vehicle will likely be ready to undertake its maiden flight in May. The long-awaited inaugural flight is targeting a 4-day launch window that'll open no later than May the 4th from Space Launch Complex 41 at the Cape Canaveral Space Force Station in Florida. Vulcan will carry Astrobotic's new Peregrine lunar lander together with 24 payloads on a journey to the Moon. Included will be 11 payloads as part of NASA's Commercial Lunar Payload Services project. Also aboard will be 2 prototype satellites for Amazon's Project Kuiper broadband constellation. The third payload contains the cremated remains of people who wish to be buried in space and have the money to do it. The United Launch Alliance, which comprises Boeing and Lockheed Martin, have been developing their new 67-metre-tall Vulcan rocket since 2020. Once flight proven, it'll replace the current Delta IV and Atlas V launch vehicles, ending an era which has seen some of the greatest names in expendable launch vehicles, not just Atlas and Delta, but also Titan. The Vulcan's first stage will be powered by twin BE-4 methane liquid oxygen engines built by Blue Origin and producing 550,000 pounds of thrust each. Strap-on solid rocket boosters will be available for extra thrust, and the Centaur 5 will provide the upper stage. Now, theoretically, Vulcan could launch as early as next month. However, liquid oxygen balance has been an issue, with oxygen pumps consistently delivering around 5% more oxygen than expected into the engines. United Launch now thinks this may simply be a unit-to-unit variation issue, but further testing will be required. But for now, if all goes well, the countdown to a May launch is underway. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for March on Skywatch. Happy New Year! Well, it would be if this was ancient Mesopotamia or Rome. That's because March was the first month of the new year, going back to the earliest concept of celebrating New Year's Day at the time of the vernal equinox, around 2000 BCE. See, the ancient Roman calendar, which had just 10 months, designated March 1st as the new year. That 10-month calendar is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It wasn't really until the Gregorian calendar that January 1st marked the start of the new year. But in the beginning it was mostly Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the Reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated New Year's Day on March 25th. The highlight of the month will be the March equinox, which this year takes place at 8:24 in the morning of Tuesday, March the 21st, Australian Eastern Daylight Time. That's 17:24 in the afternoon of Monday, March the 20th, US Eastern Daylight Time, and 21:24 on Monday evening, Greenwich Mean Time. For our listeners in the Northern Hemisphere, it means the vernal equinox, the start of spring, while those south of the equator, it's the autumnal equinox, meaning a move into autumn. The day marks the point in Earth's orbit around the Sun, when the planet's rotational axis means the Sun will appear to rise exactly due east and set exactly due west to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the very word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. That axial tilt is always pointed at the same position in the sky, regardless of Earth's orbital position around the Sun. So, on any other day of the year, either the northern or southern hemisphere is tilted more towards the Sun. But on the two equinoxes, usually around March 21st and September 23rd each year, the tilt of Earth's axis is directly perpendicular to the Sun's rays. However, there's a complication called precession. This causes Earth's spin axis to wobble ever so slightly, just like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. And because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season, for example the Southern Hemisphere autumn, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subjected to small changes called perturbations. See, Earth's orbit's an ellipse, and there's a slow change in its orientation which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion gradually regresses through a 21,000-year cycle. And there's another complication. Australia and some of the other Commonwealth countries start their seasons on the first day of the month, what are referred to as meteorological seasons, rather than on the solstices and equinoxes, which are referred to as astronomical seasons. So that means Australia's autumn officially began on March 1st rather than on the day of the March equinox. Meteorological seasons are used because it makes it easier for meteorologists and climatologists to break the seasons down into more exact 3-month calendar groupings for comparing seasonal and monthly statistics. The moment of the March equinox is also important in astronomy because it's used to define the celestial coordinate system of right ascension and declination. In astronomy, the celestial coordinate system is the astronomical equivalent to the latitude and longitudinal coordinates used on Earth's surface. It's used to specify the position of objects in three-dimensional space and the direction of those objects on the celestial sphere, the imaginary globe surrounding the Earth. In other words, it lets scientists determine the position of a celestial object, such as a satellite, a planet, stars, galaxies, and so on. Right ascension, which uses the symbol alpha, is the angular distance measured eastwards along the celestial equator from the vernal equinox. On the celestial sphere, it's analogous to terrestrial longitude. Declination, which uses the symbol delta, measures the angle north or south of the celestial equator, and so it's the celestial equivalent to terrestrial latitude. Marking the vernal equinox and setting the western evening sky this time of year is one of the oldest recognised constellations in the heavens, Taurus the Bull, so named around 6,000 years ago. In Greek mythology, Taurus represents the king of the god Zeus. Zeus lusted after King Agenor's daughter Europa, who was looking after a herd of cattle. Now, being a god and with godlike powers, Zeus decided to transform himself into a powerful white bull so that he could get closer to the beautiful Europa. Now, once transformed into a bull, Zeus convinced Europa to climb on his back, and he then carried her off to the island of Crete. Taurus's head is represented by a dominant V-shaped grouping of stars. The bright reddish star in the group is Aldebaran, an orange giant 1.5 times the mass of the Sun, located 65 light-years away. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Aldebaran is the 14th brightest star in the night sky and the closest bright star to the point of the vernal equinox. In ancient Arabic, Aldebaran's name means the follower, as it appears to follow the 7 sisters of the Pleiades. It's also the first of the 4 royal or guardian stars identified by the ancient Mesopotamians. Now, that V-shaped grouping of stars near Aldebaran is known as the Hyades. It's the nearest young open star cluster to Earth, located just 153 light-years away. Between Aldebaran and the Orion constellation, you'll see a bright red star. That's Betelgeuse, the 9th brightest star in the night sky, these days more commonly called Betelgeuse. If you turn to the north now, you'll see the 2 bright stars Pollux and Castor, which represent the northern constellation of Gemini, the twins. In Greek mythology, they were brothers who travelled with Jason aboard the ship Argo in search of the Golden Fleece. Pollux is an orange-hued evolved giant star, located 34 light-years away. It has about twice the Sun's mass and is bloated out to around 11 times the Sun's diameter. In 2006, an extrasolar planet or exoplanet, designated Pollux b, was discovered orbiting the star. The planet is a gas giant, orbiting its host star every 1.61 Earth-years. The other star, Castor, is located some 51 light-years away, and it's actually a system of 6 stars comprising 3 eclipsing binaries. Eclipsing binaries are binary star systems in which the orbital plane of the 2 stars in the system lies so nearly along the line of sight from the observer here on Earth that the stars appear to eclipse each other. Looking to the northeast now, and you'll see the star Regulus, or Little King, the brightest star in the constellation Leo the Lion. Leo is mentioned by Homer in his famous 8th century BCE poem, the Odyssey. According to Greek mythology, Leo was killed by Hercules as the first of his 12 labours. Located some 79 light-years away, Regulus is a multiple star system composed of at least 4 stars. Regulus A, designated Alpha Leonis, is a spectroscopic binary comprising a rapidly spinning spectral type B blue-white star, around 3.5 times more massive than the Sun, with some 288 times the Sun's luminosity, and a small companion star, most likely a white dwarf, the stellar corpse of what once would have been a Sun-like star. The pair take about 40 days to orbit each other. Spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, from our viewpoint here on Earth at least, by their spectroscopic signatures. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then spectral type G yellow stars. That's where our Sun fits in. Then there's spectral type K orange stars, and the coolest and least massive of all stars are spectral type M red stars, commonly referred to as red dwarfs. Each spectral classification system is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So, our Sun technically is a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can have around 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. The primary star in Alpha Leonis completes a full rotation around its axis in under 16 hours. That's incredibly quick, especially when compared to our Sun's 30-day rotational period. Now, this gives the primary star an oblate appearance, and it causes what's known as gravity darkening, meaning its poles are considerably hotter and 5 times brighter per unit surface area than its equatorial region. Scientists estimate that if it were rotating just 15% faster, the star's gravity would be insufficient to hold it together, and it would literally spin itself apart. Located further away are Regulus B, C and D, which are all dim main sequence stars. Main sequence stars are those undergoing hydrogen fusion into helium in their core, like the Sun's currently doing. Regulus B and C are thought to orbit each other every 600 Earth years and are located around 5,000 astronomical units away from Regulus A. An astronomical unit is the average distance between the Earth and the Sun, around 150 million kilometres or 8.3 light minutes. Regulus B is a spectral type F white-yellow star, while its companion Regulus C is a small spectral type M red dwarf star. Regulus D is a bit more of a question mark. It's a dim star, and, at least from our point of view, it appears to be sharing motion across the sky with other members in the group. At the opposite end of the constellation of Regulus is the star Beta Leonis, or Denebula, the horse's tail. It's a luminous white star thought to be spectral type A, about half as bright as Regulus, and the third brightest star in the constellation Leo. Beta Leonis has about 1.8 times the mass of the Sun and about 15 times the Sun's luminosity. It's suspected of being a dwarf Cepheid or Eta Scuti type variable star, meaning its luminosity varies very slightly over a period of several hours due to pulsations on its surface. Also at the other end of Leo are the stars Theta and Iota Leonis, the loins of the lion. Theta Leonis is about 165 light-years away. It's a very young spectral type A white star, about 2.5 times the mass of the Sun. With an age of just 550 million years, Theta Leonis' spectra shows enhanced absorption lines for metals, that is, elements other than hydrogen and helium. This increased metallicity appears around 12% higher than the Sun, allowing the star to radiate with some 141 times the luminosity of the Sun from its outer atmosphere, at an effective temperature of 9,350 Kelvin, literally giving it a white-hot glow. Located some 79 light-years away, Iota Leonis is another spectroscopic binary, consisting of 2 stars orbiting each other every 183 Earth years. The primary star is a spectral type F yellow dwarf star, a little hotter and more massive than the Sun. Algebra, or Gamma Leonis, is a binary star system with a visible third component. The two primary stars are located 126 light-years away and can be resolved in a backyard telescope. Both are yellow giants, orbiting each other every 600 Earth days. The unrelated tertiary star, named 40 Leonis, is a yellow tinged star which can be seen through binoculars. Its traditional name, Algebra, means the forehead. Other stars in the system include Delta Leonis or Zosma, which is a blue-white star 58 light-years from Earth, Epsilon Leonis, a yellow giant some 251 light-years from Earth, and Zeta Leonis, an optical triple star. The brightest component is a white giant about 260 light-years from Earth, while the second brightest star, 39 Leonis, is widely spaced and is located to the south of the primary, with the third and faintest star in the system, 35 Leonis, located to the north. Also located in Leo is Tau Leonis, visible as a double star through binoculars. It includes a yellow giant located some 621 light-years from Earth, and a binary secondary star 54 Leonis, a pair of blue-white stars divisible in small telescopes and located 289 light-years from Earth. Also in the constellation Leo, you'll find the Leo triplet, a group of three galaxies, Messier 65, Messier 66, and NGC 3628, all appearing relatively close together. Messier 65, also known as NGC 3623, is an intermediate spiral, possibly barred spiral galaxy, about 37 million light-years away. M65 disk appears to be slightly warped, and a relatively recent burst of star formation is suggestive of some gravitational interaction with the other two galaxies in the Leo triplet, possibly around 800 million years ago. Nearby is Messier 66, or NGC 3627, another intermediate spiral galaxy, some 95,000 light-years wide and about 36 million light-years away. Gravitational interaction from its past encounters with the neighbouring galaxies in the triplet has resulted in an extremely high central mass concentration, a high molecular to atomic mass ratio, and a resolved non-rotating clump of neutral atomic hydrogen apparently removed from one of its spiral arms. The third member in the group is NGC 3628, the Hamburger Galaxy, a spiral galaxy with a spectacular 300,000 light-year long tidal trail of gas and stars. NGC 3628 is located 35 million light-years away. Its most conspicuous feature is the broad and obscuring band of dust located along the outer edge of its spiral arms, effectively transecting the galaxy to the view from Earth. Other bright well-known galaxies in Leo include Messier 95, Messier 96, Messier 105, and NGC 2903. M95 and M96 are both spiral galaxies, each about 20 million light-years from Earth. M95 is a barred spiral. Another barred spiral galaxy is NGC 2903, which is thought to be very similar in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also around 20 million light-years from Earth. Okay, let's turn to the east now and the constellation of Corvus the Crow. In Greek mythology, Corvus was a really clever crow. In fact, he could talk to people. However, after refusing to speak to the god Apollo, he was banished to the sky, together with Crater the Cup and Hydra the Snake. One of the brightest stars in Hydra is Alphard, the solitary one, so named because it appears all alone in the sky. Okay, turning to the western horizon now, and you'll see the star Achernar in the southern tip of the constellation Eridanus the River. Eridanus is one of the largest and longest constellations in the sky. Achernar means the river's end, as it marks the end of the river Eridanus. Located around 139 light-years away, Achernar is a binary star system, comprising two stars, Alpha Eridani A and Alpha Eridani B. One of the 10 apparent brightest stars in the night sky, Alpha Eridani A is a young, hot spectral type B blue star, about 6.7 times the mass of the Sun, with a stunning 3,150 times the Sun's luminosity. Achenar's extremely high rotational velocity of over 16 km per second gives it an oblate shape, making it one of the least spherical stars in the Milky Way, with an equatorial diameter some 56% greater than its polar diameter. This distorted shape means the star displays significant latitudinal temperature variations, with its polar temperature being above 20,000 Kelvin, while its equatorial temperature, being much further away from the stellar core, is only around 10,000 Kelvin. Those high polar temperatures are generating a fast polar wind, ejecting matter from the star and generating a polar envelope of hot gas and plasma. The companion star, Alpha Eridani b, appears to be a spectral type A white star with about twice the mass of the Sun. The two stars orbit each other at an average distance of roughly 12.3 astronomical units. Now, just a quick reminder that March 14th marks the yearly celebration of the mathematical constant pi. Pi is the ratio of a circle's circumference to its diameter. But it's also an irrational number, meaning its decimal representation never ends and never repeats. More than just a number, pi has important applications in astrophysics, orbital mechanics, and other fields of astronomy. It's been calculated to over 1 trillion digits, and the current record for reciting pi from memory is over 70,000 digits. Imagine sitting next to that person at a dinner party. As for me, 3.14159 is about it. Of course, as well as Pi Day, March 14 is also the birthday of the great Professor Dr. Albert Einstein. Jonathan Nally, the editor of Australian Sky and Telescope magazine, joins us now as we continue our tour through the March night skies.
G'day, Stuart. Well, we normally start our sky tour in the south, don't we? But this time we'll start with the view to the north, as seen from mid-latitudes here in the southern hemisphere where I am. So low down in the north are 4 constellations of the zodiac that are really prominent this time of year. We've got Taurus, Gemini, Cancer, and Leo. Cancer and Leo do seem a bit bare and dull for the naked eye stargazer, but Gemini and Taurus are definitely not dull. You can easily tell Gemini because it has 2 bright stars at about the same brightness, Castor and Pollux. They're very close to each other. And you can easily tell Taurus because it has a bright red star called Aldebaran, and it also has a wedge shape of stars nearby as well. It's really quite prominent. You can't miss it. Look up to the north if you're in the southern hemisphere, look to the south if you're in the northern hemisphere. Both of those constellations have lots of great star clusters too, which you can see just with a pair of binoculars. All you have to do is get even a small pair, 8x40, 7x50, something like that. You might have a pair at home or someone you know has got the pair. Get out and have a sweep around through that area of the sky because you'll see all sorts of stuff that you cannot see with the unaided eye. It's really remarkable when you first do that. You think to yourself, wow, there's all these other stars out there that I can't see because they're too dim for my eyes to pick up or they're too dim to be seen through the light pollution. You need the grunt, the magnification grunt of a pair of binoculars or even a telescope to be able to see them.
Is this what they talk about when they refer to telescopes and binoculars as literally light buckets?
Light buckets, yeah, exactly right, because your eye's sensitivity, have a certain level of sensitivity. They cannot see things that are dimmer than a certain light, certain brightness. And a lot of these stars up in the sky, of course, are very dim because they're a long way away. We can certainly see lots of them, but there are lots more there to see. So if you get a light bucket, it's basically imagine you put a bucket outside when it's raining and you put a drinking glass outside when it's raining. The drinking glass is only going to collect a little bit of water because it doesn't have a very large surface area or volume, but a bucket has got a much larger area where the water can fall into it. So if you get some optics, some glass optics, a telescope or binoculars, then they're dragging in more light because they're bigger than your eyes, and then they focus that light down into your eyes so you can see fainter things. So, yeah, that's the whole idea of telescopes and binoculars and things. You can see things in the night sky that you can't see with just the naked eye. So that's Taurus and Gemini. Now, higher up in the sky, we've got the mighty Orion, one of the best-known constellations. Take the time to see it now because in a couple of months' time, it'll have dropped below the western horizon and we won't be able to see it again until later in the year. Now, turning around to the south, the sky watchers in the south, high overhead are the 2 brightest stars in the sky, actually, Sirius and Canopus. In fact, from where I am, in March, Canopus, the second brightest star in the sky, is bang overhead in the middle of the evening. I like Canopus for some reason or other. Sirius is the brightest star of the night sky, but I've just got this soft spot for Canopus. I don't really know why. Maybe it's because it's the underdog. It's the second best.
Yeah,
but,
it used to be the brightest star in the sky. Then Sirius migrated closer towards the sun. But now that Sirius is migrating further away from the sun again, Canopus will once again re-inherit its rightful place as the brightest star in our sky.
I think it's a really lovely star. I really do. It's nice and big and bright, and it's sort of easy to spot because there aren't too many other bright stars around it.
It really is a very luminescent star.
Well, in fact, I was going to say that Sirius, which is the brightest star in the night sky, the brightest we can see at least, is a double star system, and the larger of its 2 stars is twice as massive as our sun. And Sirius' apparent brightness is around twice that of Canopus as we see it from Earth. But in fact, Canopus is about 4 times more massive than Sirius, and Sirius is twice as massive as our Sun, and therefore Canopus is intrinsically much brighter. It just seems a little bit dimmer than Sirius because it's a lot further away. Canopus is 310 light years from Earth, while Sirius is only 8.6. But Canopus is 8 times more massive than our Sun. It's putting out a lot more energy. It's bigger and brighter, but it's a long way away. Now, heading south along the Milky Way, past Sirius and Canopus, we come to the far southern constellations, such as the Southern Cross and Carina. The Southern Cross at the moment is on its left-hand side in the mid-evening in March. But if you're awake around about 2:30 or 3 o'clock in the morning, get outside and have a look and you'll find it much higher in the sky and standing straight up now. Turning to the planets, and Venus and Jupiter really are the stars of the show this month, no pun intended. Both can be found above the western horizon after sunset. So go out after sunset and look to the west, which is the direction, obviously, the sun goes down. And look, you cannot miss Venus and Jupiter because they're both very, very bright. Jupiter is the one down below and Venus is the one above. And Jupiter is getting lower and lower in the sky, however, as the days go past, because it's about to head around the other side of the sun from us. Well, in fact, it's around the other side, but we can still see it, but it's going to move right behind the sun from our line of sight. So by the end of the month, it'll be gone from view, lost in the sun's glare, and we'll have to wait till later on for it to come back. Venus, on the other hand, is getting higher and higher as each week goes past, so you won't have any trouble seeing it. Big, bright, white light. It's a thing where I get a lot of people saying, what's that big bright star out in the west? It wasn't there last night. And I say, I was there last night. You just didn't notice it.
I always get lots of people asking me about UFOs when we talk about Venus for some reason. I don't know why, they
That's
just
right.
do. And I tell them, well, that was probably Venus you saw in that direction. And they go, oh, no, it wasn't Venus, definitely not. And I go, oh, so you saw Venus as well, did you? And then there's always this pause in the conversation.
Yeah, look, people do get a bit confused by it because when bright things are up high in the sky, so you've got a bright planet that's up high in the sky, like say Jupiter when it is at a particular point in its orbit where we see it more overhead, a lot of people don't look up, right? They spend their time looking down or just looking ahead of them. They don't look up, so they don't notice it. So all of a sudden, when you've got a big bright light, a planet like Venus or Jupiter that's down lower towards the horizon, you think, that's not normally there, is it? What could this possibly be? It's just because people don't look up very often, which is a bit of a shame, and I think that's a lot to do with city dwelling as well. If we all still lived in the country where the night skies are darker and the air's clear and everything like that, and you're more in tune with nature, then you probably wouldn't make these mistakes. But it's just one of those things that people don't pay attention to what's going on in the night sky. You could sort of understand that, I suppose, but they're missing out, that's for sure. Now, Mars can be seen about halfway up from the northern horizon, as seen from mid-southern latitudes. It's much smaller and dimmer now than it was when it was at its closest to Earth a few months ago, and it's not going to improve in that sense for a long time to come, for another year or more. It's going to be probably about 18 months, in fact, before it starts to get close to us again. So that's Mars. It just looks like a sort of a medium brightness, reddish sort of star. Now, Saturn has been behind the Sun for a while, but it's going to come back into view by mid-March. You'll have to be an early bird, though, because you're going to have to get up before dawn and try and spot it above the eastern horizon in the hour or so before sunrise. If you take a look on March the 20th, you'll see that the moon is quite close to Saturn. So if you don't know which one of those lights out there is Saturn, have a look on March the 20th in the early hours, and the bright star-looking thing that's closest to the moon will be Saturn. And from that point on, you'll be able to follow it each night, as you know where it is. And finally, it's March, of course, so the equinox is going to occur. It'll be on the 21st here in Australia, but on the 20th in other parts of the world that are a day behind. The equinox, of course, is when the sun is above the equator, and it's the day when we get almost equal hours of darkness and daylight. So the southern hemisphere, it indicates that winter is on the way for us, while our friends up in the north are heading towards their summer. And that's Stuart, the night sky for March.
That's Jonathan Alley, the editor of Australian Sky and Telescope magazine. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.